Hey everyone, so welcome to ECS Academy. As we are doing previous year question paper video solutions. So this time, I'm just going to solve one very important question from analog circuit, which might frighten you. The moment you see the question, you might get scared. Oh my God, it looks very big. Okay, and answering this kind of question will not be possible in the gate examination. But I'm just going to tell you the you can say kind of method that you have to use. Okay, so that you can get the answer very quickly, right? Okay. So the question looks very bigger. Okay, this question I have taken from Gate Electronics and Communication, and the subject is analog circuit, right? So let us directly jump to the question, okay, and try to solve this question. So you can see here, this was the question asked in Gate 2017, and let me tell you guys, this year one of my friend, okay, he's from my city only, got 4 rank in Gate examination, right? So while he got 4 rank in the gate examination, so I was asking to him whether you attempted this question or not. So he said that I did not attempt this question, right? He attempted many questions and he got very good marks, and the rank was 4 obviously in gate 2017. Currently he's working in NTPC, right? So as you can see, this question looks very big, but the answer is quite small. Let me tell you again, whatever information is given in this question, okay, just to simplify your life, let us read the question. So in the voltage reference circuit shown in the figure, right? So this is a voltage reference circuit shown in the figure. The op amp is ideal. Okay, so life becomes more easy now since the op amp is ideal. Okay, if the op amp is ideal, then the life becomes more easy. Okay, you don't have to worry about the currents, okay, going into the terminals. And there are 32 transistors, right? Q1, Q2 and Q32. And but one of the very good thing they have mentioned here is all guys are identical in all the aspects, okay, all the respects, and have infinitely large value of common emitter current gain. So this is again one important point that makes your life far easier. Okay, since you have attended my analog circuit class, so as I used to discuss that if beta is pretty large, your life becomes more easy, right? In case of bipolar junction transistor, okay. So here, your infinitely large value of common emitter current gain is given. That is beta is pretty high, okay. Understand? So you can always make assumption that if the beta is pretty high, in the sense that what? Your collector current and the emitter current is going to be same. The collector current of the transistor is related to their base emitter voltage VBE by this relation. So they have mentioned here IC is equal to saturation current exponential VBE by VT. Okay, VT is nothing but thermal voltage. So see, this question has got this kind of statement, but whatever statement is given, so that your life gets simpler and simpler, and you can do calculation very easily, right? Okay, fine. So VT is given, and one more point they have mentioned here is this VP. Where is this VP? VP is here, okay, at the transistor Q2. This VP is nothing but zero point 0.7 they have mentioned, but they did not talk about what is the voltage at this point. What is the voltage at this point, okay, across the very first terminal, okay, sorry, very first transistor, what is the voltage? So you can consider this voltage as VBE, okay. You don't know what is the voltage across this, they must specify whether it is zero point 0.7 or what. Here you have considered already, right? It is given this voltage is zero point 0.7, right? But this voltage is not given, okay. The VB across the very first transistor is not given in this question, guys, okay. And what mistake we always do is we consider this VB as zero point 0.7 only, right? So if you're going to consider this VB as zero point 0.7, you will not get the correct answer in range, right? Since it is an NAT question, right? It is an NAT question, okay? Understand? So this VB, understand? Please remember this point. This is very, very important point, okay? That's what I'm telling you. This VB is not considered to be 0.7. You have to evaluate this VB, guys, okay? And once you will evaluate this VBE, since it is NET questions, you have to maintain accuracy as well. Okay. Now the question is, how can we evaluate this VBE? First of all, the very first step is you have to evaluate this VBE. VP is given 0.7, right? It's fine. So let us evaluate this. So you just keep in mind this V out, and here what is the question? They are asking the output voltage V out here to find. And they did not mention up to what decimals. You can consider up to 1 decimal place. Up to 1 decimal place, right? You can say. So this V out will be here. Okay. V out is going to be here. Understand? So you have got two branches here. One branch is this and one branch is this. So we can consider these two branches separately, right? Let me make myself little small here, and we can consider these two branches, separate them out, right? So one branch is this. You just keep looking, okay? And this potential is nothing but you can say VBE, understand? And there is a, you can say that 20K, and you know, this is V out. Okay, there is no current here. There is no current, okay? And if this is VB, this will be VB. So this point also you can say at this point, it is going to be VB because of virtual short concept, right? So we can consider one more branch that is going to be this, okay? This is 0.7 here, which is 5K resistance, okay? And this is going to be 20K. And this point has got the potential as VB only, and this is V out, right? In fact, you don't have to do all these things, right? I just want to show you that, yeah, there should be your attention, okay? Only these two branches are enough to get the answer, right? So you will get two equations here. Please remember that. Since this is a diode connected transistor, right? So what is the current flowing here? That is going to be what? Is exponential, right? VBE upon VT. Okay, this VB I'm talking about. And what is current flowing here? That is very important. So since you know what is current flowing here, that is going to be Is exponential 0.7 by VT. And there are 31 transistor. Including this, there will be total 32. But here, this current is flowing, this current is flowing, this current is flowing. All currents are same. So the total current will be here what? 30, you can say 31 times Is e raised to power 0.7 by, okay, so at this, you know, through this branch, the current which is flowing here is 31 Is exponential 0.7 by Vt. Please remember that 0.7, okay, because this is given 0.7. But here this Vb is not given, so we have to compute it. हमें compute करना है, ठीक है? तो हमें पता चल चुका है कि इस ब्रांच से कितनी करंट फ्लो रही है 31 Is एक्सपोनेंशियल 0.7 बाई Vt, ठीक है? और इस ब्रांच से हमें कितनी करंट फ्लो रही है दैट इज Is एक्सपोनेंशियल VBE by Vt. I hope this makes sense. Okay, so these two branches are there, that's it. Now you have to just apply what? You have to just apply, you can say, you can use Ohm's law here, right? That's it. Okay, you have to just find the current. See, there is a potential difference V out minus VB. Okay, current is going downward. Okay, so you can write one equation from the very first branch, and you will get from here the equation 2. So equation 1 is going to be what, guys? V out minus VBE by 20K, okay, is equal to what? The current, which is Is exponential VBE by VT. Now looking at this equation, right, you will not be able to solve this equation. I think this is clear, right? You can't solve this equation, okay? You can't solve this equation, okay, because this is non-linear equation. Understand, there is a non-linear term, exponential term is there, kind of transcendental equation, okay? You can't solve it. You can only solve this equation numerically, okay? But there is a beauty of this question, okay? The beauty of this question is from second branch, from this branch, okay? ये जो branch है आपके पास 20K and 5K resistance is there, okay? So from here you can you can equate. So the same current is going to be flowing through this, same current is going to be flowing through this. So what is the current between these two nodes? You can say V out minus VB, okay, V out minus VB upon 20k. Okay, the same current you have to equate. Okay, the same current is flowing through the between these two nodes. You can say VB minus 0.7 upon 5k, and the total current is nothing but what, 31 is exponential, right? And this time this is 0.7 by Vt, don't forget that. And this is equation number 2. Okay, now you know that in this question is is not given, reverse saturation current is not given. So what is your next thought process? Because everybody can do till this point. Okay, if you did not consider this VB as 0.7, please never consider this VB as 0.7 because it is not mentioned. This is where everyone makes a mistake. Okay, so now you know you are not given reverse saturation current is. So then how can you manipulate this? How can you solve this? Okay, so what you can do here is equation 2 and equation 1. If you divide, okay, so there are three terms, one term, second term, and third term, and there is two term only, right? So you have to take this term and this term, this term and this term. Okay, don't take this, so that if you divide this it will get cancelled, right? So what we can do here is equation 2 divided by equation 1, right? You can just do this. Okay, so if you divide this, so what you will get here is you will get 1 is equal to, because both are same. Okay, you take this in the numerator only, so it will be in 31 exponential. Okay, and this guy will go up, right? So this will be nothing but 0.7 minus VBE by VT. Okay, simple manipulation that we are doing. Okay, so you got this equation, right? So from here you have to just find VBE, because VB is not known, VT is known. VT is 26 millivolt, and okay, everything is okay. So let me write this equation here. So 1 is equal to 31 exponential, okay, 0.7 minus VBE by, you know, VT. Okay, I'm not putting these values at this moment, please remember. So you can write this as 0.7 minus VBE by VT, which is equal to ln 1 by 31, right? So you can say 0.7 minus VBE, which is VT ln ln 1 by 31. ठीक है, इसको आप ऐसा भी लिख सकते हो minus VT ln 31. ठीक है, now you can just solve this. So your VB is going to be nothing but 0.7 plus VT ln 31, right? So VT is nothing but 26 millivolt. Okay, so 0.7 plus 0.026 ln 31. Okay, I don't know what will be the value, just we can use the calculator here. So you can say that 31 ln times 0.026 plus 0.7. Okay, so your VB is going to be 0.789. Please choose this up to 3 decimal places so that you will get the accurate answer. I hope this makes sense to all, right? So your VB is going to be 0.789. Now what you have to do here is you have to choose equation number what? From equation number 2 only, just since you want to find this V out, and V out is having the connection with this. Okay, so first term and the second term, right? You just take it from the equation 2. So you can write from equation 2 first term and the second term, that is V out minus VB by 20k, which is nothing but VB minus 0.7 by 5k. Okay, just put the value and kk gone from both sides. Since we have to find V out minus 0.789 upon this becomes 4, 0.789 minus 0.7 upon, you know, nothing, 1 will be there, right? So you can just, you know, cross multiply here. Okay, if you're going to do cross multiplication, so it becomes what, guys? It will be nothing but you know, V out minus 0.789 which is nothing but 4 into 0.789, okay, minus 4 into 0.7. You see how I am calculating. I'm not using calculator at this moment. So this becomes V out is equal to, you can take this guy that side, so and take 0.789 common, so this becomes 5 into 0.789, right, minus 2.8. Okay, so just use the calculator again. So 0.789 into 5, right, minus 2.8. Okay, so you'll get answer as 1.146. Since they are asking up to one decimal place, so your approximate answer is going to be 1.1. Okay, this is the answer for the question. Okay, so this question can be done, you know, in 2 to 3 minutes. It will take certainly 2 to 3 minutes because you have to calculate everything. Okay, so if you are going to consume less time in 1 mark question or any other question which are quite easy and straightforward, which can be done using observation or intuition or shortcuts, right, conceptual shortcuts I'm talking about. So you can dedicate some time to solve this question, because in this question you have to do some sort of calculation. I mean, these calculations are not difficult, but you have to understand that if there is an exponential term in the right hand side, okay, and there is a linear term in the left hand side, you can't solve it, okay, unless you go for numerical calculation. So you have to find some idea, right? How can you manipulate them? That is what the job here is. They are testing your basics, that's it, understand? They are checking your calculation, that's it, understand? So I hope you might have enjoyed this calculation. So if you have any sort of suggestion or feedback or any sort of comment, you can do on this in this video comment box, right? So I will get back to you. Thank you. Keep learning.